Welcome to today's CCSP study session. Today I'm going to be going over domains 3 and 4. I want to start by talking about the Uptime Institute and different uptime classification tiers for data centers. So, as you know, the Uptime Institute is an ISC squared approved organization that provides tiers for data centers in regards to their ability to maintain operations in the event of an outage. Okay, and it's the level of redundancy that the data center has available to it to continue operations. So in cloud security, there's a common term known as uptime, and that's measured in percentage. Okay. So the industry standard currently is 5 nines, 99.999%, and that equates to only a downtime of 6 minutes per year. Any other uptime classifications are usually measured in 0.99 or 0.999, 0.999, and those would be known as 2 nines, 3 nines, or 4 nines, etc., etc. So 5 nines would be 99.999, and the number of nines is the fraction of a percentage point after the decimal place. Okay, so we're talking about the section here. This is 3 nines right here. So when it comes to redundancy, you need to have redundancy when it comes to electrical power for individual servers and for the facility as a whole. So for individual workstations and servers, that would be in the form of an uninterrupted power supply, or an UPS. And an UPS is a device that the main power line comes through, it sits in the middle, and then provides power to the workstation. So the workstation is actually drawing power from the UPS, and the UPS is drawing power from the main power line. In the event of a power outage, the UPS automatically kicks on, resulting in a zero disruption of power for the server or the workstation, because the UPS has its own battery. So with that battery, the UPS can power that device for several hours usually, and it's designed to power the device until a more robust solution can be developed, usually turning on a local generator. Gasoline generators are the standard in most data centers, and those will be turned on, and then they'll provide power for usually up to 72 hours. Some data centers have also switched from gasoline generators to batteries or battery systems that can be charged with alternative power sources. But for most data centers, it's going to come in the form of gas generators. You're also going to need communication redundancy. So if phone lines go out or if internet connectivity goes out, the ability for the data center to provide connectivity to its clients and to its to those it serve needs to be maintained. It's a little harder to have redundancy when it comes to communications or ISPs than it is with power. Because you need to have, if an ISP, an internet service provider, goes down, unless you have an alternative internet service provider in your region, it can be difficult to be able to get another option for that data center. Some regions only have one ISP, or ISPs share the same type of infrastructure. So if there's a disruption, say a line goes down or a fiber optic cable is cut, then they would disrupt multiple ISPs. However, in some regions, it is possible to gain internet supply through multiple ISPs in the event of a disruption in the internet connectivity. Some regions can also support, though it's the bandwidth is questionable, a satellite-based or a wireless-based internet system and a landline system. The most data centers and web applications need to provide high-speed access. This type of alternative resulting in using a system that doesn't rely on landlines can be effective. Personnel, there also needs to be redundancy with personnel. If there are any personnel disruptions, or if personnel are unable to come into the data center for whatever reason, you need to have pieces in place to ensure that services can be maintained in the event of that disruption. So do the right personnel have the right knowledge? You have multiple personnel covering each position? Or do you only have one person who has the knowledge necessary to fulfill a role, and if you lose that person, the organization is in a sorry state, or it can no longer provide service? It's a disruption in availability because that person has all the knowledge necessary to fulfill that role. That's where redundancy with personnel comes into play. All right, so we talked about ups, generators, and power lines. And then I want to talk about the Uptime Institute. Let's take a look at their website here. Now, the Uptime Institute provides these data center tiers. There's 4 tiers, tier 1 through 4. 4 being the most robust and 1 being the least robust. So if you go to the Uptime Institute's website, you'll get an introduction on their standard. They provide like a blog on IT resiliency, and their main focus is this tier classification system with which data centers subscribe to and are classified by. So the Uptime Institute has been criticized for being very vague with their guidelines, but at the same time, their guidelines do provide a very good classification system, I think. They are purposely vague, in my opinion, because each data center needs to be evaluated in its own terms. So let's take a look at the different tier levels, and maybe you'll get an idea of what I mean here. So these might seem a little vague, but at the same time, each data center is unique. So providing a certain percentage-based criteria or a more specific criteria might not always be the best solution. So tier 1 data centers are the least robust. They're essentially, you can think of them as just warehouses with power. If any scheduled maintenance is going to require critical systems in a tier 1 data center to come offline. So that's a very huge disruption, any scheduled maintenance. Okay? And you'll see common themes here with each of these tiers. Malicious and negligent personnel activity is going to result in a downtime. So you see this is fairly vague, but at the same time, if you combine all of these subpoints together, you can get an idea of how the data center operates. Unplanned maintenance may take systems, regular systems, and critical systems offline. So critical systems will definitely come offline there, may take regular systems offline. And then annual maintenance is required, which includes a full facility shutdown. So annual maintenance is going to mean a full facility shutdown. So clearly a tier 1 data center is not going to come anywhere close to that 5 nines we talked about, the level of uptime. Tier 2 data centers, scheduled maintenance are not going to disrupt critical system, so much better than tier 1. And then you've upgraded from malicious and negligent personnel activity may result in downtime. That's upgraded from will result in downtime. Unplanned outages may cause downtime. Okay, so an unplanned outage is is less of a concern than a tier 1. Still, we're not approaching that 5 nines of availability. This type of data center may have a downtime of, or an uptime of maybe 99%, which is still several days of downtime. Tier 3 data center. This is where you get, these are the higher quality data centers, tier 3 and tier 4. Tier 3, an unplanned loss of one system may cause downtime. An unplanned loss of a system will cause downtime. So this means one individual server, and this would mean a whole system. Okay. So if you lose a whole system or a whole set of servers, it's going to cause some downtime. But if you lose just one device, it may cause downtime. Redundant power supplies are in place for all systems. So now you have your redundancy when it comes to power. And then scheduled maintenance will not disrupt critical systems, but may increase the risk of outages. So here, scheduled maintenance is not going to cause an outage, but it may increase the risk of an outage because during that scheduled maintenance, backup systems or the primary systems are one of those is going to be offline. So there's no backup available, essentially is what that's saying. And then tier 4 is where you have full redundancy. This is where you can have the 5 nines of availability and up. You can even have 6 or 7 nines of availability. Full power and component redundancy. A loss of power is not going to disrupt critical systems. A loss of a single component or system is not going to cause an outage. And personnel activity is not going to cause an outage of critical systems. So here you have complete redundancy of each system, and there's a backup for basically everything. Okay. Okay, let's talk about some different vulnerabilities when it comes to this domain. So we're in domain 3. We're talking about already 3.1. which is the physical infrastructure and the uptime errors. Okay. I think we've talked about a secure data center pretty well, but I would like to touch on humidity and temperature. Let's talk on humidity and temperature real quick. And then I'm going to get into some vulnerabilities. Okay, so when it comes to heating and temperature, the authority is the American Society of Heating, Refrigeration, and Air Conditioning Engineers, or ASHRAE. Okay? They provide standards for heating and humidity when it comes to data centers and electrical components. When it comes to humidity, ASHRAE recommends a dew point between 42 and 59 degrees Fahrenheit, or 5.5 to 15 degrees Celsius. Relative humidity is 60%. The thing is, with high humidity, you'll have condensation. Okay, that's where water particles adhere to metal, or they adhere to different components. And when you have that condensation, what you're going to have is corrosion. Okay. Also, the humidity in the air can lead to oxidation of different metals. You know, some metals used in electrical components, like servers, are corrodable, and that corrosion will cause a decrease in the electrical connectivity between components. It's also going to degrade the efficiency of electrical current moving through, and it's going to get rusty. I mean, it's rust, okay? Or oxidation is rust, so you don't want your data center getting rusted. Low humidity, on the other hand, causes a static buildup. Okay, so you don't want to have your humidity too low. Okay, so with too low humidity, you have an increased chance of static discharge. Static discharge can damage electrical components. Think about it in the winter when you go to get in your car and you touch the door handle, you get a static shock. Same type of concept happens in a data center. If there's low humidity, you're going to have a static shock. And that static shock can happen and just fry a circuit board or a delicate piece of equipment. And then there's an increased risk of degradation of your equipment. So you want to have some humidity, but not too high of humidity. Temperature, a recommended temperature is between 64 and 81 degrees Fahrenheit, or 18 to 27 degrees Celsius. Okay. Obviously, a high temperature can overheat equipment. Data centers run very hot. So in order to maintain this 64 to 81 degrees Fahrenheit, you're most likely going to need air conditioning running all year round, no matter what region you're in, because that equipment is going to generate a lot of heat, and that heat is going to build up, and data centers are enclosed spaces, so it's going to stay trapped. So you need air conditioning, you need ventilation to get that heat and move it somewhere else. Rapid heating of components is very dangerous in a low temperature environment. So if you have a low temperature environment, it's too cold, and you spin up components or you engage components and this heat builds up, that heat can cause metal to expand and contract very quickly, which can cause to cracks, or the cracks basically within equipment, or metal expanding too quickly can pull apart certain components. And this is going to happen over time. It might not happen all at once, but as that component expands and contracts due to the temperature in a low temperature environment, due to heating up and then cooling down if it's cycled on or taken offline for maintenance, then over time it's going to degrade the equipment. You're going to have problems, you're going to have breakdowns. And then also for individuals working in a data center, if you have temperatures that are too low, like approaching freezing, you have a health concern, because you have people who need to touch electrical components, and they have to work with electrical components, they have to work with metal, but you have near freezing temperatures. You can have problems where, frostbite, or people touching a piece of metal and their skin gets frozen. So there's health concerns at a very low temperature. Higher temperatures cause overheating. Lower temperatures have their also problems. So you want to have just basically think of like a tropical or sub-temperate environment, okay? You want to have like a nice sunny island in your data center with a cool breeze. Okay, we touched on heating. Let's talk about some vulnerabilities here. And if anybody has any questions, just please ask in the comment section. I'll try and get to all your questions. And if there's any topics you want to go over, please shout out. So, okay, let's talk about input handling. Okay. Particularly when it comes to web applications. Input handling. Inputs are any data that can be entered into an application for processing, essentially. Okay? So inputs should be treated in a general sense as untrusted. When you have a user input, you should not explicitly trust that input. That input should be treated as untrusted and treated as malicious even until it's validated or verified. Okay, so you need input validation. And that's the process of determining if inputs are safe for consumption by the application. So let's take an example of a web application where a user has to type in a username. Okay, so instead of if there's no input validation, a user could type in a query like this. All right, select accounts where the customer ID matches this ID parameter of basically anything. And where I get that is from this string of code. Select accounts where the customer ID, get the parameter of the ID and this apostrophe. Okay, this apostrophe denotes pulling all accounts basically. So if the web application that had a database were to store this or accept this input would be treated as code, and the web application would try to return all of these accounts. That would lead to data theft or data exfiltration from the database. So clearly that's undesirable. So in order to prevent that type, the username should be set to only accept inputs that are maybe text-based or text with numbers. No special characters like this, or the apostrophe, the asterisks, or quotation marks, even parentheses. Maybe just letters and some numbers. Or the username can only be 10 characters long, so then you don't get this entire string. But if there's improper input validation, then you could have this entire string, this entire piece of code, and the web application might accept that as code. In the same sense, one last thing. If you put as a blacklist, a list of characters that you don't want, and you put the apostrophe in that blacklist, you are saving yourself so many headaches, and you are closing off so many different attack vectors. Because this apostrophe is used, especially when it comes to SQL, in so many different attacks, it's critical. So if you close off that door for attackers, you're really protecting yourself. You're really hardening your web application just by doing that, just by putting the apostrophe in your blacklist. In fact, any special character, but especially the apostrophe. All right, error handling. So what happens when application fails improperly? If an application fails, what do you think should happen? The application should shut down, should deny access, right? Okay. But if an application fails and allows further access, that's known as what's called a fail open. Fail open allows additional access to the application, but now the application's in an error state, so normal security measures might not be working. When a system crashes, or an application crashes, or a website crashes, the error code that's displayed should have very limited information. Okay, it should just say maybe access denied. It shouldn't provide any additional information other than that. Sometimes based on the message in the error, the attacker can identify what operating system is being used or glean more information from the device, because what happened to cause the crash is reported in the error, and that's reported to the user. That should only be reported in the logs that the system administrator or the website administrator or application developer can retrieve and look at and determine the cause. It shouldn't be released to everybody. It shouldn't be released to the user. It should be shown. So if a web application fails, it should just give the minimum amount of information saying that there is a problem. The default error message should not be shown. It should just have something very generic like access denied. Nothing else should be, no error code should be shown, nothing of that nature. You don't want to give the attacker any indication, because if an error code comes up, all the attacker has to do is copy that error code, search for it in a search engine, and then they'll find out what operating system that applies to or what was used to program the web application. Also, when it comes to errors and error reporting, you need to make sure that a program will not fail and then begin to report multiple errors over and over and over again in a method that will tie up system resources, tie up web resources, and make more of a problem for itself and for other applications. Okay, misconfiguration or weak configuration. This is basically poor security hardening. Okay? This encompasses any configuration setting that is going to lead to a problem or lead to a vulnerability. A misconfiguration could be leaving open an unnecessary port or using an insecure protocol. Say you use point-to-point tunneling protocol for your VPN to access your web application. Well, there's problems known with point-to-point tunneling protocol, so that could be considered a weak configuration. Using FTP without any security mechanism, that's a weak security protocol. There's no security there, so that would be a misconfiguration. Anything where security features are disabled. You're running an endpoint, you don't have any antivirus software, or you're running a web application and you're accepting any API input. You're not doing any data validation on your inputs. That would also be a misconfiguration. Or your patches are out of date. Your web server has multiple patches that need to be installed, and you've been putting them off, or they're on the very low priority list in your patch management process. Those are also reconfiguration or misconfiguration. Default configuration. This is the configuration that's provided by the vendor. This will include default usernames and passwords. Many vendors will include open ports by default. It will use certain protocols by default. And if you're a security professional who uses these default configuration settings, you're opening yourself up to multiple attacks. Okay. Any attacker who gathers or understands what device you're using is going to try the default configurations first. They're going to see if any of those default configurations are still in place. They're going to try the default administrator username and password, a default account username and password, ports and protocols that they know just from common knowledge, because the default configuration applies to every device of this type. So they're going to try those different attack vectors that they know will work if the device was not changed from its factory setting. This is a primary concern, especially for smart devices, because smart devices are often overlooked. Most people go to their refrigerator, get milk or something cold. They're not going to go to their smart refrigerator thinking, I need to harden that device. Something to think about. All right, resource exhaustion. This occurs when you have system resources that are consumed in an inordinate amount by a process or an application. So when it comes to a web application, this is going to, if the web application uses too much information on the server, or it fails in a way that requires a, like we talked about error reporting. If the web application fails and errors are reported over and over and over saying that the web application is in an error state or has failed, the multitude of errors can lead to resource exhaustion, where resources are allocated to receive these errors or to generate these error messages, and it just builds on itself due to specific way the web application is crashed. Or you can have a web application that's poorly configured, where it requests a certain amount of information or it requests resources to perform a function, and that function can then be put in loop. So before the first process is finished, the web application requests more resources to perform maybe the same function, and that function is hanging in a hanging state where it does not finish, and then the attacker can make it request more resources and more resources in an never-ending loop, leading to an exponential buildup of system resources consumed until maybe the entire cloud server crashes. So that type of attack is known as a resource exhaustion attack, and that takes advantage of flaws within the web application code to consume more system resources on the cloud server, whatever server that the web application is running from, until that web server itself crashes. And this is going to cause it's a denial of service type attack. It's going to cause a loss of availability for any client on that using that cloud service. Okay. Okay, let's talk about a few more vulnerabilities. I think this is pretty good. Do we have any questions so far? No questions so far. Let's see. Okay. Let's talk about a zero-day attack. Okay, so zero-day attacks are pretty well known. This is a type of attack that occurs when no patch or no security countermeasure has been put in place to counteract that attack. Okay, so a zero-day attack is basically unknown to the security community. So this type of attack is incredibly dangerous because there's no countermeasure in place currently. The attack has been discovered by usually a persistent threat group, an advanced persistent threat group, or an APT, or just independent hackers. Whoever discovered the threat that may be shared on the dark web or shared with other hacker communities, sold on the black market on the dark web as a type of exploit, until it's discovered by the security community and addressed and countermeasures are put in place and it's listed as a vulnerability and known, it's known as a zero-day attack because there have been 0 days since a patch has been developed. Okay, so these attacks can exist for a long period of time, even years. There have been many attacks that have existed for years until they were discovered, and then countermeasures were put in place. Even when countermeasures are developed, it's going to take quite a while for those countermeasures to be pushed out to clients, to customers, and to different security practitioners for the word to get out about the zero-day attack, and then for people to actually implement the patch because testing needs to occur, and the patch has to go through each individual's organization's change management board and their patch management process. So zero-day attacks are of a pretty high concern, but you have to understand that they can exist even once a countermeasure is developed. Okay, just because a countermeasure is developed doesn't mean that the attack method goes away. Though once this is classified and a patch is developed, it's no longer considered a zero-day attack. Okay, just think about it in that sense. But know that even for many years they can exist, and there's still a threat even after countermeasures develop because that the security behind that countermeasure doesn't come into effect until organizations actually address it. Okay. Let's see, I want to talk about a couple different vulnerabilities today. I think we did a good job doing that. So I'm going to wrap up this study session. Next one we'll do on a little bit more on domain 3, and I'm going to cover domain 4 next time. Cloud application security, which there's quite a few questions on the exam about cloud application security, particularly when it comes to web applications, because those, face it, web offerings and cloud service offerings form the bulk of the CCSP exam. So cloud application security is incredibly important. But thank you very much for attending, and I'll see you next time.